Hello again. Hello again, everyone. It's Professor Lucien. This is lecture 16, Lockout Tagout. I'm really excited about this lecture because I'm going to quickly go through a modified version of a presentation that I got from Georgia Tech Research Institute. I updated some of the statistics and I reduced some of the redundancies. And so I'm going to go through it really quick. And then I'm going to show you what I have for you because I had a representative from Brady Corporation come in and do a guest lecture on this. And I still have links to everything they provided. And it's awesome. So it's going to be the best part of this entire lecture. First, this is from lecture 2, when I provided you the updated list from fiscal year 2018, the most frequently cited standards. You see that number 5 on the list, and this is for both general industry and construction, is number 5. If we took out the 2 construction, it'd be number 3. So it's a frequently cited standard, and it's typically cited severe because when it doesn't follow lockout tagout, it tends to be a permanent disability or possibly a fatality. So here's a breakdown of the citations that went out to industries as broken down by industry. I calculated the overall average, so it's about 5,500. But the highest one I could find was the manufacturing sector. The average was about 8,300. Lockout tagout, or basically the de-energizing of machines, is designated for servicing and maintenance. That's really what it's designated for. Machine guarding, which we're going to cover, I believe, lecture 18, is during normal production operations. We're also going to talk about electrical safety, which is one of the components of the things you're trying to de-energize or control when you're going to be working on a piece of equipment. But we're going to cover everything first, then we'll go electrical, and then we'll go into machine guarding. So this general industry does not, cover these other industries. It doesn't cover under normal production operations. Also, it says cord and plug under control. So, and this is probably something you can relate to. So if you're to go into your garage or your dad's garage or whatever, and he's got like a table saw or a reciprocating saw or whatever it might be, any device that is just like a plug, you just plug it in. If you can unplug something and like stick it in your pocket or be in control of it, it doesn't need to have lockout tagout. It's more or less when you're like at a sub panel and you have to turn off the sub panel. So it's usually electrical sources are usually above your typical household. So you're talking 220 or higher, in which you pull the switch. And that's when you lock it out, because you don't want somebody to turn it back on while you're working on it. De-energize it. You could either be exposed to the energy source, or it could actually activate the machine, and then you could get caught up in it. Here are the different energy types. Electrical, very obvious, both shock and to get a machine moving. Mechanical energy, so if something is already moving, you got to make sure that there's a brake to it, so you don't get hit. Hydraulic is, liquid under pressure. Pneumatic is air under pressure. Chemical is a little bit more sophisticated. I actually had cited a hotel, for lack of lockout tagout for their pool system, because they completely evacuated several city square blocks, and I went in and investigated. And what they had done is, after a long holiday weekend, their pool was kind of cloudy, but the custodian or whoever took care of the pool typically was on vacation. So they called in a pool guy. He came in, saw the murky. He knew he had to shock the system. And so he went in and he removed the screw for the tower that disseminates. As the water circulates, it adds the chlorine to it. And it might even been bromine. And so he saw the tablets, and so he filled up the tower, and then as he was screwing the tower cap back on, all of a sudden it just exploded, and he was doused in bromine acid and everything else. So he dove into the pool to protect his eyes and his face, but the gas that was produced evacuated everybody, because it was like a sort of a chlorinated or brominated gas, and that stings when you breathe it in or it touches a mucous membrane. And so basically what they had done is, in order to descale a tower, so after it runs for a while, there's like this buildup scaling. And so what you do is you add muriatic acid to it, but then you got to turn off the pump. In doing so, it causes the water to become murky. And so it was a really bad call. If you're going to fill up a tower with muriatic acid, it should be locked out and tagged out. You should be the person who's going to flush out the muriatic acid and then re-add the bromine. And it was a bad situation all around. Thermal as well. There could be stored thermal heat or delivery system, like a compressed or a high pressure steam. But there's other things as well. Anything that could be delivered to a machine that if left on could affect the person or start up the process needs to be locked and tagged out. What this basically means is you can't just do this alone. You can't walk up to a machine and go, I'm going to figure this out myself. You either have to have a maintenance person who knows all the energy sources or contact the company or whoever installed the equipment. You need to know where all the lines of power or energy go to the machine, and then know which valves are the ones that turn when you can turn it off or on. You turn it off, and then you need a locking device, something that prevents anybody from moving it from the closed position, and then a tag as far as who is the person who has the key that has the ability to remove it in order to put it back on. And well, they'll get into it later when you watch the Brady stuff, but you should assign a particular color, or you should even have the photo of the person, so you basically know, you should know whose lock it is without even having looking at the tag. But the tag needs to be there as well. And this is for any servicing and maintenance. So the normal operators typically aren't involved. It's usually people who have specialized training that go through the lockout tagout procedure. One thing I want to say is this is considered a performance standard, which means in order to be compliant, you as the employer have to demonstrate that it's effective. So you have to go a little bit further in than if you just come up with a program. But even though a program should be based on evaluation and the best solutions, you have to demonstrate that this is an effective technique in order to de-energize a system or isolate energy. An affected employee versus an authorized employee. An affected employee is someone who may be in or near during a service or maintenance. The authorized are the maintenance people or the servicing people. There's a lot more training when you're authorized versus when you're affected. Capable of being locked out. I don't know if I've ever seen a system that can't be. Even when you have potential energy. Let's say you have a press and it's a heavy press. And let's say if a line or a brake was to give out, it would slam down. Well, you can put in blocks. And what you should actually do is then rest whatever that potential weight is on the block, and then it could never give way. You need to have an energy isolating device. Well, you need to be able to have close it down or somehow shut it off. There's usually a way. And if you don't have a way, put one in. I know that one reason that somebody may not de-energize before they do any maintenance or service is, I'm going to give the example of electrical, is if you're relying on the basic circuit breaker in order to de-energize, and that circuit serves multiple machines or multiple stations. Well, what you need to do is you need to put in sub-panels for each individual piece of equipment so it can be locked off right at it versus having to, because then you're actually shutting down those other operations. And I know I observed this when I was in graduate school at UW-Madison. I worked with a group that we were evaluating the maintenance staff, and they were changing out the ballast in lighting without shutting it down. And they did this because one circuit was servicing classrooms and the hallway. So they're working in the hallway while classrooms were going on, and then when a class is open, they go in and change them out there. This is 205 volt power, and what they were doing was they had gloves on, they had a non-conducting ladder, and so what they do is they carefully, with special tools, remove the line that was called the hot line, or the power line, and they would cap it, and then they'd do their work, and then they'd be really careful when they put it back on. This is a bad practice, shouldn't be done, and in fact, several years after we did our observations, I said this is not a good idea. It's just a matter of time before something gets missed or mixed up. Somebody did get shocked and killed in doing this kind of work at Madison. Okay, this is pretty self-explanatory, I think. It's whether it's machine broke down or you have like a preventative maintenance schedule. It's the machine is going to be opened up. It's not going to be in production. It's shut down for whatever reason to either get it working again or make sure it keeps working as needed. You do need a written program. You do need each piece of equipment needs its specific procedures, even unless they're exactly the same machine, which is pretty rare. Then you can share them, but each machine really needs its own. You need to again train the authorized and the other. What was the name? Affected. And then you do need to periodically review. And a lot of my interns do lockout tagout review. Here's the. I'll show you a picture of one before. This used to be you think you like have a list, like shut that down. Now everything is laminated, it has pictures, things are color coded. I almost would like it that maybe the checklist or what you go through is like on a tablet, and with other sort of technologies as far as where you are and everything else. It'd be great if a person goes, okay, you're going to go through, and then there's like a video that explains first thing, explains kind of reviews what the issues are, what this machine does, and then it goes, okay, now what do we need you to do is find this, and there's like a picture of it, and they show it, do this to it, and then click OK. And when you click OK, another device like verifies that it's correct. I mean, it would almost be foolproof at that point. There'd be a lot of extra technology, but it would be foolproof. Yeah. Got to make sure that people do this too. I was once on a walk around, and there's a guy working on a machine. They were giving me a tour before I was going to do the mock OSHA audit. And when I walked by the guy who was working on the machine, he kind of looked over his shoulder at me, and I'm like, why did he do that? And I asked the people giving me the tour, I'm like, is that locked and tagged out? And they went and found out, and it wasn't. So we happened upon it. Poor guy got in trouble, and he had to go lock and tag it out then. Machine has no potential stored for energy. These are the documentation. The same thing. If you can eliminate the issue, don't need it. Single source, so if you can unplug it and keep in control of the plug, the isotope will completely be de-energized machine. Okay, so there's different exceptions, but you need to document whenever you do this stuff, and a supervisor needs to be involved with it. It's much like confined space entry, which we haven't covered yet. We'll cover in the 6th module. So there's all kinds of energy control procedures, starting with the notification of employees. You prepare for shutdown. There are steps for shutting down. You should even have, if there's a unique way in which to start the system back up, as to talk about that too. Not only do you need to isolate the energy, lock and tag it, you also then need to attempt to turn things on to make sure there's no stored energy. It doesn't happen all the time, but they want to make sure that all stored energy is either dissipated or not there. Here's an example of a equipment specific. It's got pictures and they use color coding. That's the way it should be done. So here are the steps. I'm just going to quickly go through them. This is notification of employees. This is preparing for shutdown. This is actually shutting it down. You're isolating everything. Using lockout tagout. You see, an emergency stop is not considered lockout tagout. Either is a interlocking guard, and we'll talk about it when we do the safeguarding, but there are certain things that there's a guard, and when you open it, and there may be multiple reasons for opening it, what it's supposed to do is prevent any more cycling of the process. That's also not considered lockout tagout. You need to actually isolate the energy, ensure that it's been dissipated before you go in and start working. Relieving stored energy. Stored energy examples are here. Verify that it's been isolated. And then once you've completed your work, release from lockout tagout. So it seems fairly simple. In most cases it is. But if you have a project that takes multiple days or multiple shifts, you actually have to, as a new shift comes on, once, if it's somebody, let's say you have an electrician and he's going to leave and there's a new electrician coming in, he has to remove his lock, and the new lock has to go on by the new electrician who's going to be going in. There needs to be this sort of control that way. The things you use, Master Lock has great sets, Brady has great sets, and you see this is what it basically looks like. There's more of it. They've gotten really creative with developing covers for all sorts of valves and things like that. Make sure it can't be disintegrated. You need to know who locked it out. Okay. These are just demonstrations. All good stuff. You've probably seen this stuff without really even knowing it. At least annually, you need to review. Just make sure that everything is working out. Yeah, make sure you certify when you do those reviews. Authorized employees require retraining. Affected, not so much. It's when everything's changed. Yep. And make sure there is evidence or documentation that the training was done. This is just testing or positioning machines, so this is just making things work better. If you have multiple people working and you just don't, it may be easier for everyone to store keys or multiple things just in a lockbox, and then you lock it. So therefore, nothing can be activated until everybody finishes their work and removes their lock, and then you can get into the lockbox. Then you can remove the keys and remove the other locks. It's just sort of a secondary. Sometimes it gets really messy when you have too many locks on everything. It's just, you're allowed to do that for group work. There's minor servicing exemption. Yeah, pretty self-explanatory. And that's everything. So, that only took about 15, 16 minutes. So I want to show you what I have for you, because this is pretty awesome. All right, so I have a link to OSHA's lockout tagout page for pretty self-explanatory. Take a look at this. It's good stuff. More importantly, though, is everything else that I have for you. This is awesome. Safety Professionals Expanded Guide to Lockout Tagout. This is directly from Brady. So when there's an ANSI standard that sort of supplements or supports an OSHA standard, you have to pay for those ANSI standards. But companies who sell products that are meant to meet or exceed OSHA standards will actually wove in all the requirements and let you know what they've provided meets those standards. And so that's where you can get this free stuff online that addresses that. So this is really great stuff. Also, there's this elements of a visual lockout procedure. So this is what they do. They use color coding, they use pictures, they use arrows. It should, I don't want to say dummy proof, but it's meant to be very easy to follow so you can protect yourself. And it's all laminated and everything. And then finally, they've got this checklist for a program. What you can do is go through, and they've got the OSHA paragraphs actually identified. That's pretty cool. Additionally, there's all these great videos. You have to watch these. Go and check this stuff out. It's awesome. And it should give you much better insight to what the OSHA page has or what I had just covered. Because I really covered sort of a 100-foot viewpoint of what lockout tagout is. Because it does need some level of complexity or sophistication depending on the equipment. Sometimes repositioning things or having well colored and labeled valve points are all really important, and they need to be accessible as well. So Brady points all that stuff out. So in the next lecture, we're going to get into electrical safety and arc flash, which relates to this. Then we're going to get into machine safeguarding. So the next, this lecture and the next two are pretty much, intertwined.